Hey guys, welcome back to math. Today we're going to do some more work with connecting partial products in the standard algorithm so you can see where all those pieces lie and we can get some more practice in with the algorithm. You're going to need your workbook today. We're on page 145. So if you don't have that out and open, please get that now. I'm going to help walk through how to solve the first one because as you see, our partial products now has some weird bracket things off to the side. I want to show you what that's for and so you can see it being connected to the algorithm. So let's start with the algorithm. Work it with me, please. So we have 7. That is not a 7. That is a 6. We have 6 times 7. So I'm going to put some little math off to the side here so I can keep track of it. 7 times 5, that's 35, which means I need one more set. So plus 7, 35, 36, 37, 38, 39, 40, 41, 42. 2 down here. Carry the 4. Now I've got 6 times 3, which is 18, 19, 20, 21, 22. Remember, this isn't really an 8, it's an 80. So 80 times anything is going to always give us a 0 here. So put it there first. Get rid of that. Now I can call this an 8. 8 times 7. 8 times 5 is 40. 8 times 2 is 16. So 56. So 6 down here. Carry the 5. 8 times 3. 8 and 8 is 16. 17, 18, 19, 20, 21, 22, 23, 24. Plus 5 more. 25, 26, 27, 28, 29. Alright, add those together. So I got 2, 6, 7, 8, 9, 10, 11, 3. So there's our answer. I'm going to show you how this connects to over here. So first thing I did was the 6 times 7, and I got 42. Then I did 6 times 30. 6 times 30 was 180. This bracket here is to show you when you add those together. So 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Carry the 1. Now you can see how these two partial products end up getting our first line here. So let's see if it's true for the second one. Second one was 80 times 7. 8 times 7 was 56. We put the 0 back. Then 8 times 3 was 24. And then if I add these two together, I should get this bottom line. So 0, 6, 9, 2. And I do. So I know I got the bottom part correct as well. And when I add those together, 2, 6, 7, 8, 9, 10, 11, 3. I end up finding that I have the same answer. So that is what these two are for. Now it's your turn to try. Oh, maybe I'll help you with this one too. This one's a little bit wonky. So these gray boxes, so you still have to work out the same full problem. The difference is now it has some gray boxes to figure out. So these 3 gray boxes are where your points are coming from. But there's no way to figure out what goes in these boxes without actually doing the math that goes with it. So we're going to walk through this problem to be able to figure out what these blank boxes are. So first, you have 5 times 4 for 20. Okay, the 0 carried the 2. Fantastic. Then 5 times 5 for 25 plus 2 more is 27. There's the 2. This needs to be a 7. Okay, then you went to your second line. You'd cross that 2 out, put a 0 in, right, because this is a 20, not a 2. Then they did 2 times 4 for 8, 2 times 5 for 10, which means this is also a 0. That is how you fill these ones in. Is you have to walk through the whole problem. You don't have to record the whole thing, right? So it already filled out the answer for you, but you do have to walk through the whole problem to figure out what these blank numbers are. You cannot just guess and put something in. So let's jump over here. The first thing we did was 5 times 4. Actually, pause here. And I want you to fill in this partial products bracket on your own and then push play. So 5 times 4, 20. Then we did 5 times 50. 5 times 5 is 25. Put the 0 back. So let's check. 0, 5, 6, 7, 2. Look, it's right. Then we did 20 times 4. 2 times 4 is 8. Put the 0. Then 20 times 50. 2 times 5 is 10. Put the 2 zeros back. So if we did this right, this number should come out to our bottom bracket here. 0, 8, 0, 1. And it is. And then we add these up. 0 and 0, 0, 8, 9, 10, 11, 12, 13, 14, 15. Carry the 1, 2, 3, 1. We have the same answer. Okay, your turn to fully try it. So, you're gonna, there you go. You're gonna try solving, ooh, it's a 3-digit, but I know you can do it. I have faith in you. Guess what? The system doesn't change. No matter how big any of these numbers are, you always go, you have to pass this 3 out to everybody. Okay? There's also this over here if you get stuck. So I want you to pause, do both of these, the algorithm and the partial products, and then push play. We'll see how you did. So, like I said, the pattern, the system, the steps don't change no matter how big this number is. We have to keep doing the same thing we're doing. So the first thing is 3 times 2, which is 6. 3 times 0, 3. 3 times 4. You have to pass this 3 out to everybody. 3 times 4 is 12. We didn't have anything to carry up top, which is fantastic, but this is a 60, not a 6. So if I put that there, now I can treat it like a 6. 6 times 2 is 12. Carry the 1. 6 times 0 is 0, but we're going to add 1, which makes it 1. Then you have 6 times 4 for 24. Okay, so then we add it. 6, 2, 3, 5, 2. 1, 2, 3. Uh-oh, I put the comma in the wrong spot. 1, 2, 3, comma. So 25,326. Notice over here that your bracket is now holding 3 partial products instead of the 2 like before, because your top number is a 3-digit number. But when we add these 3 pieces together, we should still get this top 9, and we add those bottom 3 together, we should still get this bottom line. So let's see if we're right. 3 times 2 is 6. 3 times 0 is 0. 3 times 400, which is 3 times 4 is 12. 2 zeros. So 6, 0, 1, 2. All right, we got the top layer done. It's correct. So 60 times 2, but really 6 times 2 is 12. Put the 0. 60 times 0 is 0. 60 times 40, get rid of all those. 6 times 4 is 24. And we have 1, 2, 3. 1, 2, 3. Do you see why this one is not as efficient? It is not as easy to line up your numbers with this method. You can see I've had quite a few problems with it, trying to guess how far out I need to push my numbers, and so it gets really squishy. Part of that efficient piece. Easy, quick, gets you the right answer. This could very easily get me the wrong answer because I don't have my numbers lined up. Look, my 4 and my 1 are technically stacked with this 0 kind of floating in no man's land. This is how you end up getting wrong answers. It's very hard to predict where to put your numbers unless you have those lines in there already. So, 0. Yeah, see how I have to like make this curved line, that's how you end up getting the wrong answer. 2, 1, 4, 2. And there we have it. Same thing here. So then I'm just going to do it here. 6, 2, 3, 5, 2. And there we have the same answer. All right, your turn to try one of these ones on your own. Again, it's a top 3-digit number, but it's the same process. Pass it out to everybody. You need to walk through the whole problem to figure out what all these blanks are. You have 4 of them. 1 here, 1, 2, and 1 over there. Then come over here and fill this part in. Pause and solve. Okay, let us see how you did. So, 6 times 8. Sorry, guys. 8s are doubles, or I can do 8 times 5, which is 40, plus another group of 8, which is 48. So here's the 8, so this must be the missing 4. Plus 4 there. Okay, so then you did 8 times 0, which is 0, plus 4 for 4. 8 times 3. 8 doubled is 16, 17, 18, 19, 20, 21, 22, 23, 24. So this is also a 4. Okay, so then you cross this out so you don't get confused. You put the 0 down. Now you have 4 times 6. 6 and 6 is 12. 12 and 12 is 24. There's the 4. There's the 2. I'm going to put a little add sign there so we don't get confused. Then 4 times 0, which is 0, plus 2. So this is a 2. Then 3. 4 times 3 for 12. There's the 2. Here's the 1. Now let's walk it out over here, all those steps that we did, and see if we got it right. So we did 8 times 6, which got us 48. Then we did 8 times 0 for 0. Then 8 times 300 for okay, and we have an 8, we have a 4, we have a 4, and a 2. This one was pretty easily lined up, which is good. Okay, so then we did 40 times 6. Oh, 24. Then we did 40 times 0, which is 0, and then 40 times 300. 1, 2, 3, 1, 2, 3, 12. That's a little bit better lined up, but again, still pretty hard. This makes it a lot easier and don't have to keep track of all the zeros floating around. So 0, 4, 2, 2, 1. And we got it. I didn't put the commas in, but there it is. All right, so let me add it together. 8, 8, 4, 5, 6, 2, 4, 1. And we end up with the same answer. All right, try this last one here. Pause and solve. All right, this one only has 2 blanks, but again, you can't just guess. You have to walk through the whole problem. Don't just jump over here to this 9 times 6 and hope you get the right answer. So, 6 times 9. What I'm doing first, 6 times 9, so 9 times 5 is 45. Plus 9 more, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. There's the 4, there's the 5. Fantastic. Then, there it is again, 6 times 9 for 54, plus the 5 more, 54, 55, 56, 57, 58, 59. So there's the 9, there's the 5. It's a good place to check too. If I would have gotten like 58 or 57, I know something is wrong because this is a 9. So I can go back and start again to make sure that I can get this worked out right. All right, so then They cross that out. I see their line there. They put the 0 down. Good work. Okay, so then 7 times 9. Well, guess what? I know that 6 times 9 is 54. So this is just 9 more. 54, 55, 56, 57, 58, 59, 60, 61, 62, 63. There's the 3. There's the 6. Good job. And then 63 again, but I have 6 more. 63, 64, 65, 66, 67, 68, 69. So this is a 9. Now, make sure we have the right answer going here. There should be 4, 9, 10, 11, 12, 2, carry the 1, 9, 10, plus 5 is 15. Oh, look it. This should be shaded because they're missing a plus 1. 6 plus 1 is 7. So 6 times 9 was 54. Then 6 times 90, 540. 4, 9, 5. Got it. Then 70 times 9, which was 63. Then 70 times 90, 630. Add those together. 3, 6, 7, 8, 9. 6. Oh, I missed a 0. See? Yep. Missed a 0 there too. See how easily you can mess things up? Gotta slow down. This is why this is more efficient than this one. Look at that. I missed both those 0s. Okay. So then we add this together. 4. Now they're super not lined up too. Look at that. Oh my goodness. Look how many errors I could have off of this. I could be adding all kinds of weird things and getting all this math wrong. Good thing we have the algorithm to keep us straight. 9, 10, 11, 12. So 5, carry the 1, 7. Whew, we got it. Eventually. Good work today. You are going to jump back to 144 for your independent work today. And look, it's just like what we worked on today. Only 3 of them. Try this one first, then fill this in to make sure you got it right. Same thing with both of those. So, before we go, I have one last thing for you here. This is Sammy's standard algorithm practice. Take a look at it. Do you think he's right? If not, why do you think he got it wrong? Take a look here. Pause if you need to. So what I'm hoping you're realizing, 46 groups of 60, and he's only got 400 for an answer? That's a lot of groups of a lot of stuff, and that's a very small number. So something right here, this is why we use that estimation tool, something here should tell you real quick that something's not quite right. This is a lot of groups. This should be only 10 groups, right? Putting a 0 to the back, putting a 0 to the back, which means multiplied by 10. So where did the other 54 groups go? Something has gone wrong. So we go through and kind of look through his work here. This is what teachers do when you get the wrong answer. This is why showing your work is important. It might not be something very difficult. So let's look. So 6 times 4 is 24. There's the 4. There's the 2. Good work. 4 and 4 is 16 plus 2 more. Okay, so 18. You cross that out. But there's our problem. This is not a 6. This is really a 60. So what should be here? A 0. So he has done all, well, maybe Sammy's a girl. Sammy has done all this beautiful multiplication, but forgot that this is a 60, not a 6. So now as a teacher, I can go to Sammy and say, hey, Here, we got to remember to do this one little tiny piece instead of going, I have no idea what Sammy knows, what Sammy doesn't know, because all I have is their answer. This is why showing your work is so important. We know that they can add. We just need to make sure to get that extra 0 at the bottom. Good work today. We will continue our work with the algorithm tomorrow, and I hope you have a great night. See you tomorrow, guys. Bye.